Hi, this is Dr. Abdul Rahim. So today we are going to discuss a new topic from the matrices, which is the solving the system of equations by using the Gaussian elimination method, right? So what is this Gaussian elimination method? So Gaussian elimination method involves the transforming the augmented matrix into an upper triangular matrix and getting the solution by backward substitution, right? So what we do in this Gaussian elimination method for solving the system of equations is for the given system of equations, we will write down the augmented matrix and we will reduce that matrix into an upper triangular matrix and then solve by the backward substitution. Okay, so let us solve this problem so we will understand better. So now for the given system of equations, the augmented matrix is written as is equals to, so the coefficient of x1 is 2, coefficient of x2 is 1, coefficient of x3 is also 1, the constant is 10. Similarly, in the second equation, coefficient of x1 is 3, coefficient of x2 is 2, coefficient of x3 is 3, the constant is 18. In the third equation, coefficient of x1 is 1, coefficient of x2 is 4, coefficient of x3 is 9, coefficient, the constant is 16. So this is the augmented matrix. Here, this is also called the coefficient matrix. So here we have the coefficients of the variables. So coefficient of x1, coefficient of x2, and coefficient of x3 from all the three equations. So this is also called as a coefficient matrix, and this matrix is also called as a constant matrix. Constant. So these are all the constants which are present on the right hand side of the equation. So it's called a constant matrix, right? Okay. So now what is the procedure here to solve the system by using the Gaussian elimination method is we will reduce this matrix into an upper triangular matrix, and by backward substitution we can solve the uh, equations. So now so how can we make this into an upper triangular matrix is consider this matrix 3 by 3 matrix. So if we see this one, the diagonal, so we'll try to make the elements below the diagonal as zeros. So now we have to make this element as 0 and this element also as 0 and this element also as 0. So then if I make these three elements as 0, then this augmented matrix will be reduced into an upper triangular matrix, right? So what we do here, we will use only the row operations. So what I will do here is R2 is changed as 2R2 minus 3R1. So I will try to make this element as 0 using the element of R1. So here we have 2, here we have 3. So I will multiply this with 2 and I will multiply this element with 3 and subtract them so that this element becomes 0. Similarly, so here it is 1 and here it is 2. I have to make this element as 0. So therefore, R3 is changed as 2R3 So 2R3 means this will become 2, and here we have R2. So therefore 2R3 minus R1. So there then this element will become 0, right? So for this one I have multiplied with 2, and here I have multiplied this with 3, so that we can subtract them, then this element becomes 0. So here we have 1, here we have 2, so therefore I will multiply this row 3 with 2 and subtract row 1, so there that element will become 0. So now therefore A by B is changed as, what happens? So row 1 is same, 2, 1, 1, 10. So now row 2, apply the operation, 2R2 minus 3R1, 2 into R2, 2 into 3 is 6, 2 into 3 is 6, minus 3 into 2, right? So 2R2 minus 3R1, 2 into 3, minus 3 into R1, that is 2. So 6 minus 6, it becomes 0. Next element 2R2, so that is 2 into 2, 2R2, 2 into 2, minus 3 into R1, that is 1. So therefore 2 into 2 is 4, 4 minus 3 is how much? 1. Similarly for the third element also, 2R2 minus 3R1, so that is 2 into 3, 2R2, 2 into 3, minus 3 into R1, so that is 2 into 3 is 6, 6 minus 3 is 3, right? And for the fourth element, 2R2 minus 3R1, so 2 into 18 minus 3 into 10, right? 2 into 18 is 36, 36 minus 3 into 10 is 30, 36 minus 30, how much? Is 6, right? So now let us do the transformations for the row 3. R3 is changed as 2R3 minus R1. So 2R3 is how much? 2 into 1 minus R1 minus 2. So 2 minus 2 is 0. Now apply for this also, 2R3, 2 into 4 minus R1, R1 is 1. So 2 into 4 is 8, 8 minus 1 is 7. Apply for this element also, 2R3 minus R1, 2 into R3 is how much? 2 into 9 minus R1 is 1. 2 into 9 is how much? 18. 18 minus 1, so that is 17. Next, for the fourth element also, 2R3 minus R1, 2 into 16 minus R1 is 10. So 2 into 16 is how much? 32 minus 10, that is how much? 20. 20, right? So therefore, the augmented matrix is changed. Now, so now what we will do? So now we have see the diagonal elements now. So now we have made this element as 0, this element as 0. Now this element we have to make it as 0, so that the elements below the diagonal are all 0. Now I have to make this element as 0, so I will use the operation R2, R3 is changed as R3 minus 7R2. R3, I want to make this element as 0 using this row, this element. So R3 minus 7R2. So therefore, A by B is augmented matrix is equals to, the first row is same as it is. So it is 2, 1, 1, 10, right? Next, apply the operation. Second row is also same. 0, 1, 3, 6. For the third row, we have to apply this operation R3 minus 7R1. So R3 is 0, 0 minus 7R1, 0 minus 0 is 0, right? R3 minus 7R2, R3 minus 7R2, R3 minus 7R2. So what is R3 here? 7 minus 7 into R2 is how much here? 1. So that is 7 minus 7, that is 0. Now apply for this element also. R3 minus 7R2, R3 is how much? 17 minus 7 into R2, R2 is how much? 3. So that is 17 minus 21, that is how much? Minus 4. Next, apply the operation for this element also. R3 is 22 minus 7 into R1, 7 into R, wait. So have we done 7 into 17 minus 7 into R2, R2 is 3, right? 22 R3 minus 7 into 6, right? So R3 minus 7 R2, R3 is 22 minus 7 into R2 is 6. So that is 22 minus 42. How much? 22 minus 42. So that is minus 20. Right? Now if you see the main diagonal, so the elements below the main diagonal are zeros. So therefore, now this matrix is reduced into, this is upper triangular matrix. Upper triangular matrix. Upper triangular matrix. So what we do in the Gaussian elimination method, we take the augmented matrix and by using the row transformations, we reduce the matrix into an upper triangular matrix. That means that all the elements below the main diagonal should be equal to 0. So we made the elements below the main diagonal as 0. Here if you see here, this is the main diagonal. The elements here are 3, 1, 4. So we made them as zeros by using the row operations. Now this is the upper triangular matrix. So now we can find the solution by backward substitution. So what we do here, right? So what we do, here, we will, from here we will write down the equations. So from above, comma, the equations are So now this is the coefficient of x1, this is the coefficient of x2, this is the coefficient of x3, and this is a constant on the right hand side. So therefore, it is 2x1 plus x2 plus 1 into x2 plus 1 into x3. So that is x3 is equals to how much? It is 10. Now this is coefficient of x1, that is 0 x1. So plus 1 x2. So 1 x2 is x2 plus 3 x3 is equals to how much? So this is the coefficient of x1, 0 x1 plus 0 x2 minus 4 x3. So minus 4x3 is equals to how much? Minus, right? This is 1, this is 2, this is, right? So from this, from 3, what happens? From 3, what happens? X3 is equals to minus 20 upon minus 4. So that is equals to 5. So this minus gets cancelled. 4 ones, 4 fives, 20. So therefore, we have x3 is equals to how much? 5. So we have x3 is equals to 5, right? Okay. So now what we will do? We will go and put this x3 is equals to 5 in 2. So put x3 is equals to put x3 is equals to 5 into what happens here? If I put here, so it becomes x2 plus 3 into x3. X3 is how much? 5. So 3 into 5 is equals to how much? 6. So this implies x2 plus 5 3 is 15 is equals to 6. So this implies if I move this 15 to the other side, it becomes minus 15. So x2 is equals to 6 minus 15. So that is equals to minus 9. So therefore we'll get x2 is equals to, therefore x2 is equals to minus 9, right? X2 is equals to minus. So what we will do now? So put x2 is equals to minus 9 and x3 is equals to 5 in 1. So we will substitute that here. So what happens here? So 2x1, x2 is how much? Minus 9, minus 9, x3 is how much? 5, minus 9 plus 5 is equals to how much? 10, is equals to 10. So minus 9 plus 5 is how much? Minus 4. So 2x1 minus 4 is equals to 10. So if I move this minus 4 to the other side, it becomes 10 plus 4. So 2x1 is equals to 14. So then we have x1 is equals to 7, right? x1 is equals to 7. So therefore, the solution of the given system of equations is x1 is equals to 7, x2 is equals to minus 9, and x3 is equals to 5. So if you want to verify, so you can substitute in the equations and you can verify the solution. So this is the method of finding the solution of the system of equations by using the Gaussian elimination method, right? Thank you for watching my video. If you like my video, kindly hit the like button and as well as subscribe to my channel for watching my video. Thank you.